Okay, here are some other properties of logs, some things that I kind of skirted past because we're not in a face-to-face setting where I, I have my routine down and I keep hopping here and there. So when we started this conversation about logs, we said if I have the function y equals b to the x, okay, that's our exponential function that is 1 to 1. It has an inverse. We had all those properties about this goes through the point 0, 1. Its domain is all real numbers. Its range are positive numbers. And we said, oh, well, this mysterious inverse exists, and it goes through the point 1, 0. Its domain was only positive numbers. Its range is all reals. And we didn't know what to call this. Okay. When we worked through the last section 4.3, we said, well, the inverse, that's our logarithm. The inverse of b to the x is the function log base b of x. So if we hop back to section 4.1, there are some things we know. We know that if we take the composition of a function with its inverse, then all that's left from that is plain old x. Okay. What that means is if we take b to the x, and in place of the exponent, if we plug in this other function up here, then we don't have to look at that and try to figure out how to do the arithmetic or know what that means. By definition, okay, what we were told is that that's going to be equal to x every single time. So if I have 5 to the log base 5 of x, that's equal to x. If we have I keep saying that, 9 to the log base 9 of 3, that's equal to 3. If we have 4 to the log base 4 of x squared plus 1, that's equal to x squared plus 1. If the bases match, base and the base and the base and the base, if the bases match, then all that's left is this stuff inside. Whether it's a number, whether it's a letter, whether it's an expression, whatever it looks like, that's what we have. The same is true if we take the composition in the reverse order. If we have log base b of, if we plug this function in to here, every place there's an x, then by definition, that's just equal to x. Okay, this is more often what we'll see in the problems that we'll do in the rest of the chapter. Okay, we'll have a base here of 3 and a base here of 3, so the answer is just that exponent. And the faster that you recognize that, then the shorter the problems become. We don't have to write down quite as many steps. So if the bases match, then the answer is the exponent. So if we have log base 2 of 4, that on first appearance may not say much to you, but if you realize that 4 is 2 squared, we say, ah, because these 2's match, then the answer is the exponent. Probably should have used something other than a bunch of 2's there. Okay. So if we have log base 10 of 10 to the x plus 7, that's just going to be x plus 7. If the bases match, and this is the more common way we'll see it, but your author throws some of these in here also. Okay, this is a little messier, but if the bases match, then this is all that's left. Okay, here the exponent is all that's left. And that's a nice thing to keep in mind. Okay. Some other things to understand is when you're using your calculators, and this is where I'm sad we don't have time in class to sit and push buttons and for me to help you if you need the help. But your calculator should have two buttons. Or it might be the same button and the LN might be the second function. You might have to use the shift key or the second key or whatever's on your calculator. And if your calculator has an LOG button, it should also have an LN. When you hit the LOG button on your calculator, it is automatically log base 10. Okay, if you want log base 4, too bad. If you want log base 6, too bad. The LOG button is log base 10. The natural log button is log base E. E is what's called the natural base. And they call it the natural base because in nature, the growth and decay of items, they kept coming back to this base. So it's a number kind of like pi, where it happened often enough, they said, let's give it a name. Okay. So when you see Ln on your paper, understand that that's automatically log base E, where E is this value here. Not a value you have to discover or solve for or come up with. The Ln means log base E, and plain old log means common log. So if you see things like natural log of e to the x on your paper, understand that ln means log base e, and so that looks like the problems we were just doing. If the bases match, all that's left is the x. So natural log of e to the fourth is going to be 4. Natural log of 1 over e, because 1 over e is e to the negative 1. Natural log of 1 over e is negative 1, okay, and so on. So common log, natural log, composition of functions. When we are trying to solve for x at the end of this chapter, we have to be able to use this composition of functions to be able to get back in the properties of logs that we learn in 4.3 to be able to solve for x. And so these are these sections you're just getting familiar and comfortable with seeing these relationships and recognizing that this would just be equal to the exponent, that this would just be equal to that 3.